Okay, I think it's about time to get started. For everyone who's sitting on the other end of the webinar, thank you for joining us today. This is a co-collaboration between AppySec and Redspin, division of Synergistic. This is on API Security 101, establishing and managing a security API program. Let's see, next slide. Okay, so in today's highlights, we're going to be talking about just really quickly a rundown of what an API is and what it really looks like from the back end, and why it actually does make up about 80% of the internet. So we're going to see an example of APIs in action, and then we're going to talk about the Owasp top 10. We're actually not going to cover down on the top 10. We're going to cover down on the main top, I believe it's 6 or 7. And then we're going to talk about breaks in APIs and API security challenges and the benefits of implementing a API security program. So I am Andrew Binder. I'm a senior red team consultant here at Redspin. I have been in the community for really longer than I care to admit, but I'll put 20 years down. That seems like a fair number. Primarily, I've done penetration tests for the last 10 years as my job. I started out in the military and I've worked for everything under the alphabet soup in the Washington, D.C. area, CIA, NSA, DIA, DOD, etc. I've written a book for Hacking with Callie, and I've presented pretty much across the world. These are just some of the ones that I have done in the past. Ultimately, my passion is IoT hacking, but what I really love about IoT hacking is that we are able to look at an entire ecosystem, and that ecosystem is generally controlled by API calls in the background between mobile devices, the physical devices, gateways, integration with the web applications, analytics, etc. So we do a lot of heavy amount of API security testing when we're going through IoT products. And then we'll move on so I can introduce Dan.
Yeah, hey everyone. I get 3 bullets here, not nearly as impressive as Andrew, but I'm pleased to be here. I've been in cybersecurity space for 20 plus years as well. All on the vendor side, so some of the companies you might recognize, Qualys, Anomaly, and ArcSight, where I've had executive roles at these companies in leading marketing, leading sales, leading business development, and now I'm here at AppySec, and have really come up to speed on the challenges, the headaches, frankly, that APIs present, and looking forward to having a discussion here today about that topic.
Alrighty. So just to drop in a little bit about APIs and why we're actually here today, we live a very data-driven life. You may have seen this slide in other webinars that we've done. This is me harping on this. Whether I'm talking to someone on the street, whether I'm talking to someone in the business space or giving a webinar, data-driven life. We are fully connected. To think that we're not, I think that you can actually live off the grid. That's like a pipe dream for some of those people that want to live out in the backwoods. However, if you have any involvement in society, you are always connected one way, shape, or form, whether it's through work, through school, through mobile platforms, social sharing, etc. Problem with that is that's a lot of data to move. That's a lot of data to really analyze. There's a really overwhelming search for that data access. I don't remember the last thing that I've ever gone to trying to sign up for, I don't know, even taking my kids' school pictures. I still had to sign up and make an account. Everything underneath that was driven by that web application was an API. Maybe I shouldn't have been taking a look at that, but that is my job as a security professional to pay attention to those things. When you drive down the street, your cameras, when you come to a stoplight, smart cities, sensors, how your power company monitors your influx and outflux of power, everything is controlled by data in some way, shape, or form to make those business decisions or calculate risk or calculate money that is owed for services rendered. We cannot get away from data, and there's just an overwhelming amount of it. People within the organizations want access. They want interoperability, mobility, security. And that is, if we can get our hands on the data, we want to take a look at that. Not just from a security perspective, but the end user. Think about all the people who might be on this call, or you definitely know someone who has a smartwatch or does a step counter through their phone or fitness tracker, or if you're on a treadmill, things like that. All of that data, people love to calculate it. They love to keep track of it. They love to monitor it for themselves. Now, on the security side of that, being myself, I want to tear it apart and I want to make sure that it's as secure as possible and minimizing risk to clients and their patrons. So next slide, please. All right, so let's talk about what an API actually is when we look at it in the background. So let's say that there is a customer who wants a product. This product in this case being makeup. A very simple thing, especially my wife goes on and orders pretty much everything online, from groceries to makeup to clothing, school supplies for the kids, etc. When they have a product in mind, they go out to the website, they're looking through all of the products. If you're trying to transfer all of that data, every single page that is rendered, it's very inefficient. So what's going on in the background is the worker bee, and that is the API. The API goes through and pulls lists and pulls data and pulls all the metrics, feeds it to a backend website. When they click purchase, it gets logged, goes through payment system, it gets an email that's sent to an inbox, it gets assigned for delivery, even packaging, the packing slip, which conveyor belt it's going to get printed out to, and all of that is handled through the analytics of the cloud. So we have an API that from just one purchase can go through and make automated decisions and process products or services or other data based on the initial action. Well, APIs are the worker bees that cause all of that to function together. We don't see it, it operates in the background, but it does make up about 80% of the internet. Next slide, please. So the benefits of an API that we have a GUI-less transfer of data. So if we had to render out every picture, every table, every marker, every little thing on a page every time, you would see a surge of bandwidth used. Well, when you're handling large amounts of customers, thousands at a time, that can definitely, it's a lot of service that's used, a lot of bandwidth that's used by your customers. So by using APIs in the background, you can actually minimize that. You also minimize the attack surface because you're just moving the data back and forth. So you're offloading the process from the server having to load all of that and then just transferring the necessary data and rendering it in the user's browser. So we end up conserving the bandwidth. Also, we have the ability to overlay data on top of requests. So if you have thousands of users accessing the same data at the same time and you need to track inventory and things like that, you can actually keep a very fast track through different types of headers, through the E tag, through the last modified, and inventory can be tracked and people can see stuff happen in real time. A lot of stock market applications and things like that also do that same type of processing. There are some things that we do need to clarify about APIs before we go any further though, and that is the actual term for an API. So API is the Application Program Interface, and it is a composite of endpoints. The endpoints, which I'll talk about as we get into the technical aspects of some of the Owasp top 10, you can see that the endpoints change, but they're focused on an object. So it is an object with multiple properties in it, but the endpoints themselves are generally what are discussed when we talk about the API at its core level, when we're stepping away from its core level. So for instance, if we were to take a look at health on the right-hand side here, we have some different functions that are inside of it. So we might have a hospital system, but inside that hospital system's API, there could be endpoint for users, and then an endpoint for users info, and then an endpoint for their primary physician, any notes that are released for them tracking their API or their analytics within the API, etc. So the endpoints actually come down to the call that's made for the specific set of data that we want to render to the web application or mobile application. And then we have public versus private. In the case of public APIs, these are often allowed for developer access. For those teams that want to come in and develop applications and use data sets and allow integration into their application, versus a private API, which is generally handled on the back end. And we usually see this in testing through specific web applications where there's no documentation available. It's not meant to be touched or played with by developers. It's only meant for in-house use, and it just transfers data back and forth. Next slide. Okay, so let's go ahead and talk about the Owasp top 10. For those of you who are not familiar, Owasp is the Open Web Application Security Project. They do more than just API security, but you're more likely familiar with the Owasp top 10 for the most common vulnerabilities of web applications. They have one for mobile security, they have one for API security, and then on top of that, it's actually a really large community of thousands of different professionals working together, from coding and security to different platforms. There's a huge consortium of different companies that actually help moderate and feed data into Owasp's other projects. And I think the last time I checked, they had well over 180 different projects, everything from code scanners to all of their available documentation, testing guides, standards, and best practices. So I did mention that we were going to go over the top 10 at a high level. We are only going to cover the first 6. So broken object level authorization, broken user authentication, excessive data exposure. I don't know who named these, but I'm pretty sure that somebody was trying to keep their job somewhere. A lot of these names, when you first read them, they don't make a whole lot of sense. But as we get through talking about the first 6, it'll actually start to make a lot more sense. For instance, mass assignment is the amount of permissions that are available and visible during an API call. Excessive data exposure, lack of resource and rate limiting is a fancy way of saying there's no limit on the amount of data that can be requested by an end user or an application. So it's about conserving bandwidth and preventing denial of service and those types of things. So the names, when we get down there and we start breaking them out, they'll make a little bit more sense. But if you're fairly new to API security, some of these may not make sense right away just looking at the name. But I encourage you, stick around and we will break this down. The 7 through 10 should seem relatively familiar for anyone who's had to deal with security over web apps, mobile, or APIs. Security misconfigurations are always prevalent throughout, let's call it the history of computers. That's why we are in our jobs and doing security, is that we are always looking to improve. Misconfigurations from rushed admins and rushed developers, it happens all the time, and that's partly what I get paid to do, is find and spot those misconfigurations and help them improve that. Injection, this covers everything from server-side injection, SQL injection, command injection, code injection, client-side injection, cross-site scripting, cross-site request forgery, those types of things. Anything where you can put data in and get a different process coming out of the backside, those are pretty standard. Improper asset management is actually more of how you're maintaining your environment. This is more of a documentation process. If you're making sure that you're isolating your application and putting it into a secure environment, that you're maintaining your backups, etc. Those are more of compliancy types checks, and those are something that really have to be done by more of a compliancy specialist or someone who's going to take a look holistically at everything that's going on. And then insufficient logging and monitoring, that is literally as it sounds. That is the one actual name on here that actually makes sense for what it is. Okay, go ahead, continue on, Dan, please. All right, so let's talk about broken object level authorization. In this case, we have an API endpoint that we're looking at someone who is at a bank, perhaps. So we have a branch and a branch ID number. They have a patron number or their account number, and then we have the account info. So on the object of the branch ID, we have, we could have Tulsa, we could have Phoenix, we could have another place in Arizona, which is escaping my mind at the moment. And then we have the patron ID, obviously everyone who's in the bank and assigned to that branch. So a separate object on top of, a group of objects on top of an object. And then we have the account info. So the account info being the endpoint that actually contains all of the properties specific to the objects referenced. But in the case of the object, if Cindy was to log in, we might see a branch ID of 01 for Tulsa, and then 02 for Phoenix. As she logs in, she has her account number, which is usually a long string, but let's say that in the process of developing their backend API here, we see that it's a 5-digit number. That's actually a pretty common thing that we do see. If we were to go and change the branch ID number, could we cycle through the patron ID numbers? Now, Cindy should not see Bradley or Lucy. She shouldn't see their accounts in any way, shape, or form. However, as she cycles through those different IDs, perhaps the account info for other patrons is available per branch. And this is actually the number one issue with APIs that this is why Owasp actually has labeled it their number one. As a matter of fact, I have a disclosure, a responsible disclosure to a company later today to talk about this exact issue with one of their APIs. So ultimately, it's that one person shouldn't be able to read the object of another. And if they can, then that's no bueno. Next slide. Broken user authentication. Obviously on the left side of your screen here, you may see it says enter password and it's only 4 characters long. Anything that surrounds a user being able to bypass authentication, weak password policies, no lockout, those types of things, those are all going to fall into the category of broken user authentication. One of those might be that we may have direct access to the object after the session has died. So we also include session management into this particular category. Next slide. Excessive data exposure. This is another one that gets companies in trouble on a pretty regular basis. This slide is purposely built to be very busy, and that is because if you look in the background here, you can see Venmo.com. So about a year ago it was, I guess, and maybe just a little over a year now. Venmo, their API, actually, you could surf to it. You could start referencing the different payment IDs. So as you could see the name of the person that was involved in the purchase. It would go through the date created, how much they paid. It would give the permalink for it. There was just a huge amount of data that is possibly there. We want to make sure that when we're developing our APIs, that we're limiting what is available to the end user. We want as little processed on the actual browser as possible. So it's even though it gets to the browser, we don't want to send them an excessive amount of data and then expect the browser to process it, because there may be information in there that they just don't need. One of the common ones that we see in this category is the visibility of groups or admin accounts, things like that. Next slide. Okay, lack of resources and rate limiting. So this is on the picture on the screen here is something we actually ran into on a recent pen test about 6 months ago. There was a digital safe combination rather than a username and password for protecting administrative credentials on the network. So this was an internal application, but the API that was behind it did not lock out users attempting to, when they made, an incorrect or invalid attempt for authentication. It was only a 5-digit number, so our consultant sat there with Burp Suite and literally cycled through all 10,000 possibilities. After about 6,000 or 7,000 possibilities, the combination was discovered, and it granted us access into the application where we had access to all the sensitive information in the background. Next slide. Okay, this is going to take a half second to talk about the broken function level authorization. Many organizations that develop APIs have great intentions. And I say that because they are trying to meet usability versus security. And that's where function levels can often be broken down and permissions are mismanaged. We want to make sure that whoever has access we're following that principle of least privilege. So on the screen here, we've taken a bank headquarters and a bank branch. We can see the auditor. If we were to go look at the auditor's permissions, we see from the bank, they can process records, so they can read the records, but they can also write the records. Well, we may not want them to write the individual records. They do need to audit that, so they do need to read it, but they may not need to write. This is something where, if identified, it's something you want to sit down with the development team and say, okay, this person has access to do this thing at this level. Do we want them to be able to have that? Do we want them to be able to write? Do we want them to be able to execute, etc.? And do that for every single object or every endpoint as necessary. Furthermore, the auditor may be only processing records from the bank HQ. So if it's at the headquarters, do they need to see and read and write anything from the branch office? If that's the case, then you would give them access, but not. You may or may not want to give them, again, read or write access at the branch. Maybe it's just a senior auditor versus a junior auditor. Do you have that role separation? The next one down we have is the branch supervisor. When we looked at the permissions for the branch supervisor, we see that they have read and write access to customer records at both the HQ and at the branch. But this is a branch supervisor. Based on that role title alone, we could simply assume that the supervisor is not actually meant to have full access to read and write at the for the credit accounts for all of the entire bank, just within their own branch office. So that would be something, again, that would have to be reviewed with the developers and maybe sitting down and going through and reviewing these. And then we have the enterprise account representative. So the enterprise account representative who may be selling credit assistance services, like how to improve your credit or payback programs, things like that. They definitely don't need to write to someone's credit record for any reason. At least we would assume that based on this scenario. So we are able to say, okay, well, with certainty, that account really shouldn't have access to be able to write records or modify files within the bank, because that could cause the bank to process their alerts or fraud alerts on their accounts, or late payments or this or that, which could cause them to lose their reputation with things like Equifax. So this is definitely one of those sets of permissions where we would want to take a look at that. But as we look down at the branch level, the enterprise account rep didn't have access to read or write at the branch level. So those are actually pretty good. Okay, so I hope that wasn't too involved there. Okay, mass assignment. This is an application that we tested about 3 or 4 months ago. And it is, again, a very busy slide. I apologize. Everything in an API when testing from security is, well, it's not everything, about 90% is from text-based. So what we've got here is we've got we're updating the user details, and the user ID and the username are pretty standard, along with first name, last name. and email address. The user is able to update their personal information, say address, phone number, email, last name, etc. But when we look at the when we actually look at the submission and capturing it through Postman or Burp, we can see that the amount of data that's actually transmitted includes their account status, if they're an admin, what groups they're in. So we were actually able to just reassign ourselves to the admins group. And by doing that, when we logged out and logged back in after the update, we were able to just walk bang in as an administrator, and then we had full access to the system. We did this again twice and ended up having access at the super admin level once we found the appropriate group for that. So mass assignment really deals with what can be published and how can someone modify their data inadvertently, even though your web or mobile application says you can only edit these 5 fields. What about what's going on in the background? Do they have access to edit those things? And that's something that you really want to take a look and pay attention to. This, however, is an extremely tedious process. Depending upon the number of roles that you have, the number of permission sets that there are, the number of potential groups or silo IDs or object IDs that they're assigned to, this is a very, very tedious process for a pen tester. I would definitely recommend having a scanner in place of trying to test for this particular finding.
All right, this is where we hand off. So thank you, Andrew. So picking up on that, you know, as Andrew mentioned, you know, APIs have really taken off. You know, there's a well-cited statistic from Akamai now. You know, fully 83% of all that traffic on the internet is API based. Machines communicating with machines to serve up data, to serve up functionality, to power to power transactions and the like. And of course, you know, the side effect of you know, now these are becoming, you know, major targets for attackers, right? 90% of the surface area of web apps is API based. 90% of the breaches are targeting web applications, and by 2022, next year, Gartner predicting APIs will become the most frequent attack vector for breaches. And a very simple diagram to maybe hammer that point home. This is a, you know, a simpler version of the one Andrew showed earlier, but you know, a lot of the security focus has historically been at that front end layer, right, where we do our, you know, app scanning, where we enforce authentication and set up access controls and access rights, where we actually, you know, filter what data gets presented to the user. This is where a lot of the focus has been historically. And with the advent of APIs, it's only a matter of time before attackers discovered that has become the weak link in the chain. And you know, in the rush for developers to push out functionality, to do, you know, fix bugs, to sort of deliver on the roadmap and things like that, these APIs have become a major weak point. In talking to one large utility company recently, they acknowledge that they're embracing APIs. They're using it throughout their infrastructure now. As Andrew mentioned, you know, managing, you know, smart home devices, your utility meters, traffic lights, you name it. When the security team looks under the hood of those APIs, they regularly find that they are, quote, over permissioned, right? You know, in the rush to release code, there's not time to check every possible permutation, every possible way that API could get used, and the APIs often have these unintended loopholes, these logic flaws that allow someone to make use of the API in unintended ways, and that's exactly what the Owasp API Top 10 really focuses on. And to sort of double down on some of the comments that Andrew had earlier, here are some real world examples of each of these of the Owasp top 5 and how they actually happened, how they how they got breached. So one example here for Owasp number 1, broken object level authorization. The Postal Service had an API called informed delivery. It was for shippers to be able to programmatically access all their shipments, all the deliveries. Where are they? Have they been delivered? Who signed for them? All of these kind of details. And someone discovered that they could log in with their valid credentials, use the API, but by modifying the query string, something like incrementing the user ID, from by 1 digit, they suddenly could view all of user B's data, right? Someone else's data. And so some malicious person discovered they could use that for malicious purposes, and 60 million accounts were accessed through this mechanism. Number 2 is broken authentication. Physical is a gym mobile app. You could reset your account. They would send you a 4-digit code. You type the code in, you could reset your password. Well, of course, even without access to one's email or phone number, it would take really no time to cycle through 4 digits and gain access to whatever account you'd like on the system. For Owasp number 3, Andrew mentioned Venmo. What's interesting here is there was a feature on the home page that would show in real time the most recent 20 transactions. And the UI would filter out the details that you didn't need to know about, right? Descriptions, full names, things like that. But as Andrew mentioned, APIs will return whatever data the API is designed to access. It's not going to do that filtering. And so someone discovered that API could be called directly. They wrote a script. They queried it 100,000 times a day, and were able to access all of the transaction details to the tune of 200 million transactions over time before the vulnerability was discovered. For lack of rate limiting, similar to the Physical one, except Instagram required a 6-digit code, so 1 million different combinations. And they did, in fact, limit the number of guesses to 200 per IP address. And they put a timeout. You had to have supply the code within 10 minutes. But what they didn't do was limit the number of IP addresses that could be used to submit the code. So somebody built a little server farm on AWS, made sure they could cycle through 200 tries per IP address, and just ran through all 1 million possibilities within 10 minutes, and could gain access to anybody's Instagram account, anyone they wanted to. And then for broken function level assignment, the Bumble app, this was a classic example of all of the security was at the UI layer, very little at the API layer. So not only could someone access, and they did, the API to download the entire database, which incidentally also returned the distance of how far you were away from another user. So they literally created 3 accounts and triangulated to find exact location of every user of Bumble. But it also allowed them to modify their account settings and turn on premium features to eliminate any restrictions and the like. And this is kind of like, allowing someone to view their invoice is one thing. To be able to delete it is totally unnecessary. It makes no business sense. And so it's a great example of what type of functionality are you enabling for users, and should they have that or not? And the common thread, though, across all of these is that these are not your classic security issues. Not one of these was a SQL injection attack. Not one of these was cross-site scripting or buffer overflow or all of these kind of classic security things. These are what we call business logic flaws, right? There's a logic failure in the API itself that allows user A to access user B, or that one can try to submit the code, one of 1 million different combinations by by building a farm with enough unique IP addresses. And these are much more difficult to identify and to remediate. So there's really three main ways that APIs get secured today. So on one side, in the pipeline, you have sort of secure coding or static analysis type of solutions. And then you have in production, firewall, web app firewall type of solutions as well. Both of these are very valid, much needed, but really address kind of the common security types of issues, right? The buffer overflows, denial of service, bots, misconfigurations, authentication issues, and the like. And the third category is testing. And with testing, you can find these business logic issues, but the problem, we'll cover in a moment is really a matter of scale. And so, if we get into the testing a little more detail, this is where you're going to be able to find those most serious vulnerabilities that actually have led to the breaches. And here's a quote I like from Corey Ball. He has an upcoming book called Hacking APIs. He's a pen tester by day, and he says if you design the most secure API but don't test it, then some cyber criminal somewhere is going to do it for you. And this is what we've seen in all of those examples. These were vulnerabilities, these were logic flaws that made it all the way through the QA and testing cycle, got into production, and really are your own personal 0 days, right? These are vulnerabilities that no one's going to discover but you or someone other than you that you don't want. So why is it so challenging to actually detect and test for these things? So first of all, there's a coverage issue, which is APIs, you can't be crawled, right? You can't just sort of put a bot on it to click every link and to press every button. An API may have many different endpoints with many different methods, and of course all the different attack vectors that they might be subject to. And so you need testing that covers every possible corner, because surely a hacker is going to try to find that one corner that you missed. Let me come back. Let me do scale next. The next one is scale, which is take an API with 50 endpoints, 4 or 5 methods. You're up to 200 unique permutations. Then you've got all the different attack vectors. You're going to need thousands of unique tests to really adequately cover that entire API and to stress test it against all of the possible ways that a hacker might try to find a gap in the logic. And then lastly is speed, right? We're constantly pushing out new code, nightly builds. Development's got a roadmap to hit, fixes to push to production. And manual testing can't keep up with that pace of development. So what we've built here with AppySec and what we've done with Redspin with the API Sentry product is a fully automated API testing program. And what it delivers for you, I'll just build this all the way out, is with an automated tool to actually find those critical vulnerabilities, the ones that we've been talking about, right? These business logic failures. To automate the creation of all those tests, those thousands of different types of tests that cover the entire API, all of the endpoints, every method, every attack vector, all mapped back to the Owasp top 10 that runs at the speed of DevOps, right? The entire test, the analysis of your API, the creation of the test, the running of the test completes in minutes, not in weeks. That gives you that continuous security so that every release is going through this cycle, right? And when anything goes to production, you know that it's been properly vetted and evaluated, and is extraordinarily cost effective because we are using automation, we are using machinery to create those tests, to author those, to make sure we're covering the entire API, and then to execute them. And so a quick case study on how this has worked for one client. This one is a SaaS vendor. They actually manage highly proprietary information for their clients around sales and marketing enablement. So certainly, if I'm a user of this service, I want to make sure my competitors don't get access to my highly sensitive information. And the SaaS provider wanted to extend functionality through APIs to their customers so that they could custom integrate, they could build other workflows, gain more access to the useful information. But they wanted to make sure that this was all done in a highly secure way. So they ended up deploying our automated test capability right into their staging environment. So every night or whenever new builds push into staging to get into production, they would automatically kick off this API scanning and testing program. We'd create those playbooks, analyze the API, add any missing playbooks if there's new code that's been added since the last test, and then execute those tests and find those vulnerabilities and report them back into the DevOps cycle. So automatically create Jira tickets or GitHub or ServiceNow so that developers can see the vulnerabilities with all of the details to be able to remediate. And there's a nice quote from the director of information security. Now when their customers ask them, what are you doing to protect my data, with these APIs, he can show them, right? He can show them that they're running these tests on a nightly basis. He can show them the reports that come out of the system, and really put them at ease that their data is being well protected. So Andrew, I'll hand it back to you to talk about API Sentry.
Absolutely. So we do recognize at Redspin that your developers are busy, right? Developers have for years now been stuck in a mindset of you will hit your deadlines and you will get your code in and you will get the feature out by X date, and that often comes with risks. But as we introduce things into the DevOps lifecycle, or in this case, the DevSecOps lifecycle that we constantly try to achieve, that we're adding more to their plate. In the case of the automated portion of scanning, some organizations they have really super tight timeframes. Or they might be in startups, so they don't have the resources, the manpower available to go through and look at every finding, prioritize their risk, determine where the biggest impact is, so they can keep the ball rolling. The API Sentry program is designed to work with AppSec. So in this case, we go through and we're taking that process off your place as a continuous monitoring program. So we set up a schedule on a regular basis, and then we go through and we customize playbooks for your team based on your needs at scale at the time and process. We can also help move it into the CI/CD pipeline. We look at the risk and we say, okay, this actually got identified. Yes, it is valid. What does that really mean? And so it's a micro pen test validating all of those things. And that's where you really get the benefit out of the API Sentry program, is that it's taking the heavy lifting off of your developers, so your developers know when and where to focus their efforts. And then if they don't, what kind of bad things could really happen. For instance, if somebody was to get access to the backend database, it's pretty self-explanatory that they're able to manipulate the data or cause denial of service, erase the data, or just extract it all. But it's something as simple as a broken object level. What does that really mean, and what kind of data exposure is that really impacting to your company? So there may just be something as simple as just emails and things like that, or it may be something more risky, such as account numbers or even hashed passwords, things like that.
So I think to wrap up here, we do have a special offer here. So along with Redspin, we are offering a free API pen test. This is a live test against one of your own APIs. There's really not a whole lot of heavy lifting involved to actually run it. And we're happy to walk you through the process. We'll give you results typically within 24 hours. Actually always within 24 hours, including the test report that comes out of the system. and and then to sit down with you and actually review the findings, right? To show you the different types of the tests that we ran, the vulnerabilities that may have been discovered, what they mean, how serious they are, and the like. So if you're interested in this, please visit that URL, redspin.com/free-test, free-test. You can register there. Certainly you can follow up with us on email as well. I'm sure we can get you in touch with the right folks. And of course, you're welcome to contact either of us. Our emails are there if you have any further questions. So with that, Andrew, do we have any questions in the chat?
Yes, actually we do. For those who may not have seen it, there is a chat feature within the webinar. If you do have questions, please, by all means, submit your questions and we will try our best to get through as many as we can. If we can't get through them all, we'll make sure to try and send you an email or reach out if you've requested follow-up of any type. There is a couple really quick ones that I want to point out. Apparently, I said 10,000 PIN numbers when I was talking about rate limiting. Yes, 5 digits is 100,000 numbers. So apparently, I need more coffee and can't do math this morning. And somebody else asked, what would you recommend for better names for the risks and vulnerabilities in API top 10? Actually, that's a really good question because I know that this was sent through the board. This is all personal opinion on this point, but broken object level authorization is the exact same thing as IDOR in web applications. IDOR being insecure direct object referencing. And so we may use ID numbers, we may use folder names that are in sequence, we may use a one-up or a series of block letters, or hexadecimal or something like that. But we, in these particular cases, like that one would have been a better name just to keep the name so it would be easier for people to understand. Ultimately, there really isn't a way to get through it. There's not a way to change the names. It's community driven. So it's just something to get used to, but it is something I give a lot of people warning from as I try to go through and explain them. So that's why I harp on the names. But okay, so Dan, somebody has an interesting question in here. And where in the development to production pipeline do organizations typically insert API assessments? And is this more of a production regime or something that is part of development?
Yeah, that's a good question. The answer is really up to you, the organization. Typically what we've seen is people want to orchestrate this into their pre-production pipeline, naturally, to flag those vulnerabilities before they get into production. So that's where we see it most commonly. It's part of the nightly staging environment or part of test. Developers can use this capability directly. So there's an ability to actually go in and run a set of tests if you want to do sort of ad hoc, see if it's passing or not. But in terms of automation, it's typically in a staging environment or something pre-production. Doesn't mean it can't be run in a production environment, and certainly we've seen that happen as well. And that's just really entirely up to you. And in some cases, there may be some actual difference between the staging environment and production, so it warrants actually running the test in that fashion. One thing to mention is kind of the deployment model, which is we call it zero touch, meaning there's no source code access required. There's no agents that you need to deploy into the code itself. There's nothing in line. It's not a firewall. It's not going to have any latency issues that it introduces. The way the testing works is it simply acts as a user or another client. So it will log in to your API as user A and create a transaction. Then it will log in as user B and try to manipulate it, delete that transaction, modify it. And then, of course, that's one example of many thousands. But this is exactly what a hacker will do too, right? They're going to try to log in. They're going to try to leverage the access that you give, that you make available, and then manipulate it to some other objective. And that's exactly how this testing works as well. So there's nothing to install, nothing in line, no tuning or training, no agents. It just simply acts as another user, and that those tests can be run wherever you want, in production, in staging, in dev, whatever it makes sense. Andrew, did we lose you there?
Yes, you certainly did. I was on mute. Thank you, Dan, for that. Appreciate it. So there's another question in here, and I'll take this one, and that is there any vulnerability that isn't on the API top 10 that you think it is important to consider? Yes, I do. A lot of APIs and a lot of web application, mobile applications, they use Java weighted tokens. So those Java-based tokens are generally, when you see them and they're captured within Burp Suite, you'll see them. They're usually marked by token, and then you can quickly identify it with EY. And so what we do is we go through and we actually copy out that token and we put it through a decoder. You can only decode a portion of it because the other half of it is the signature, to make sure that the entire token is valid on itself. But sometimes what we do see coming back out of the portion that can be decoded is the certificate itself. This isn't one in particular that is covered by the Owasp top 10. There is an open source tool if you want to try this out for yourself that actually covers multiple vulnerabilities on those tokens, and that's actually called Jwt Tool. It's available on GitHub, and ultimately it will go. You can give it you give it the token, and it'll I think there's 5 or 6 different tests within the tool that allow you to manipulate that token, and then try to you would copy back in and paste it back into your Burp Suite or your Postman, and then try to replay the token and see where you can get to. And sometimes when we're doing that, especially when it's part of the user authentication process, we might be able to get SQL injection through that token. So yes, SQL injection is, I think it's number 5, or yeah, I think it's number 5 on the list. It's number 7, I think it is, for injection. And that is on the Owasp top 10. But just the manipulation of the tokens, that actually isn't really included. What's really kind of nice about the Owasp top 10 is that they did they made a more of a category rather than a particular individual finding. So for instance, the injection piece, which is I believe number 7, and that is it covers all different types of injection. So if there's any kind of injection whatsoever, whether it's SQL injection, or whether it's server side or client side, basically, that's that portion kind of covers that, as these were the top 7 out of that list. Okay, let's see. So hopefully that answers your question on that. There is actually, hey Dan, here we go. Here's a joint question. When is a scanner better than a pen test? When is a pen test better than a scanner?
I don't know, Andrew, do you want to take that one to start?
I will absolutely take that one. Pen testing is expensive. You can pay for one pen test, and it's usually, depending on the size of your test, you could be looking anywhere from, or the size of your API endpoints is what most companies scope that out as. If you're on the low end, only having maybe 10 API endpoints, you could be looking at $10,000 or so, depending on the company. I don't have prices, and I'm not involved in pricing, but at a previous company I was, and 10 was about the $8,000 mark. But then we'd have other organizations that would have API endpoints of 120 200. In one case, we actually scoped out for a company at 800 API endpoints, and then they had multiple APIs on top of that. And it was like $500,000 to do the testing, and would have taken absolute months just to be able, multiple dedicated resources or personnel just trying to go through and do that. So the cost efficiency there went from having very focused, very short testing to, oh my God, months, and being extremely expensive. With that, the scanner would have been the better solution, because by the time they paid out for a scanner such as AppySec, they would be able to go through multiple times and integrate it as part of their lifecycle and watch their trend analysis over time, go through and spot the highlight, the more critical vulnerabilities to the high, the mediums, lows, etc., and watch them slope off over time, and then perhaps have a pen test come in for a block period of time afterwards to see if the scanner missed anything that was not included in the initial playbooks that were originally configured there. One of the things that we have done in the past is the modification of XXE. Sometimes I haven't actually tested that one out with AppySec. I know it does it, but in some other tools that I've tried out, it doesn't do such a great job in that capacity. So I would say the pen tester is able to make that call, and the amount of data that is actually returned, determining whether it's excessive or not excessive, what kind of data it is. AppySec does a pretty good job of trying to figure out what's there. Oh, is this a social security number? This is a credit card number. This is etc. But that human element really plays a big difference on what kind of things come back. A scanner may come back and say, there's a hash, you should pay attention to that, where a pen tester is going to take that step further and go, that's a hash, let me decrypt that. Oh, yep, it decrypted, here's credentials, let me log in, now I have all that data. So you actually could see a true level of risk rather than an assumed level of risk. And that is the power of AppySec in being able to make those judgment calls. But the pen tester on the Redspin side is able to take that a step further to see where it impacts the company, because it may go from one little finding in the amount in a set of 40 or 50 findings to full back-end compromise of your database, and that's where the pen tester is going to kind of come out more so than the scanning tool. But that is my perspective, and I'm a hands-on tester, so I might be biased on that. Dan, you want to throw your hat in the ring?
Yeah, I mean, there's a reason I asked you to take it. I knew you'd have a more thoughtful answer, and I want to be mindful of our time here. We're getting close to the end. But my only comment would be, typically, pen testing makes sense where it cannot be automated. Where it can be automated, it's probably going to scale. It's going to run faster. It's going to be more cost effective. It'll give you more coverage. All of those things. And what we've seen in APIs is there hasn't been the ability to automate. The state of the art has only been manual testing, pen testing, and thankfully that state of the art has changed, right? And it's not to say that automation is perfect. You do want people in the process to review the results, to prioritize, to make assessments, and that's one of the nice things about API Sentry is you get that. But the beauty of the service is that it is automated. It does run at the speed of DevOps. It does give you that coverage. It does address the Owasp top 10 plus a whole lot more. And so I think my only advice is, if you can automate, it certainly makes sense to do so. And where you can't, that's when you need to go to the manual pen testing. So I think with that, Andrew, I think we can wrap. Hopefully this has been a great session for everyone.
Oh, absolutely. There is one last question, and I will answer this. It just popped in, and that is, how can your scanner know to use the application's API if there are many endpoints which aren't necessarily used by the UI? That's a really simple and short answer, and that is Swagger file, Open API documentation, or actually AppySec can actually go through at a very wonderful, fast pace and actually scan to see what you have on the back end. So there's many different ways. If you are interested in having a scan for your API, please use the link that you see on the screen. That's resbin.com/freetest. Thank you very much for attending this conference. This webinar rather has been recorded today, and it will be made available publicly. So I believe that'll be hosted on the Redspin site. I want to just take a last second to say thank you very much, Dan, for your time. I know you're a very busy man, but I appreciate you coming out and doing this talk with me. And thank you, everyone, for attending.
My pleasure. Thank you. Take care.